Formative assignment 6, feedback loops. This is due Tuesday, the 21st. As always, you're going to be graded with this rubric on your scientific reasoning. So how well you organize your ideas and make sure that one builds off of the other rather than just being a series of incomplete thoughts or unclear and unconnected ideas. And then we also want to make sure that we have enough detail in our responses. That's this second row. So you really want to make it your goal to bring in the most relevant facts, enough detail, and you use the new vocab accurately. And especially in this response, since we're going to be talking about reasoning and about different systems and loops, we really want to make sure that these cause-effect relationships are clear. So that's going to require us to use transition words, leads to, caused by, right, as a result of, in our response. All right, so let's look at the directions. Read each scenario, and then in the space provided, read each scenario, and then in the space provided below each scenario, we're going to do the following. Identify whether the climate system is in a positive or a negative feedback loop. Again, I'm just going to cue myself because I'm going to use that same strategy that we did in the reading of highlighting the details that give us clues in terms of if it's a positive feedback loop or a negative feedback loop. And then I see that we're also going to need to provide reasoning for our answer. I'm going to show you an example of how I would answer it. So let's read the scenario. As global temperatures increase, more continental ice sheets melt. Okay, so I see this word more here. This reduces the Earth's albedo, resulting in less solar radiation being reflected and more solar radiation being absorbed. Okay, that's interesting. So I see more radiation is being absorbed, right? So, and I see that in the first place, temperatures are increasing. So, first event, temperatures increase. Second, this causes ice sheets to melt. The ice sheets melting causes Earth's albedo to be reduced and not be able to reflect as much radiation, which then again results in more radiation being absorbed, meaning that as a result, temperatures increase even more. So I don't see stability mentioned anywhere, and I have quite a bit of clues that tell me that this is a positive feedback loop. So I know if it's a negative feedback loop, I'm going to refer back to my notes in the PowerPoint. So you're going to want to go back to the Google Classroom stream. Let me show you what I'm talking about. Opening the Google Classroom. So you're going to have to go back into your stream and go back to, this is the example for last week, but where Ms. Tran posts the PowerPoints for each week to refer back to the notes. All right, so I have them up here. I'm just going to remind myself what a negative feedback loop is. System process that causes a decrease in function, and it results in a more stable system. Positive feedback loops cause overall increase or amplification in the system. So that's why I'm saying I don't see any stability mentioned here. I only see increasing and amplifying functioning of this system. So for a type of feedback loop, I'm putting positive. My response, I'm going to say this is an example of a positive feedback loop because the initial, the original increase in global temperatures Let's see, what transition can I say? Caused or I can also say led to an increase in global temperatures. Let's just say further, like again, an even more increase in global temperatures. Even higher than the last time. No stability is maintained. The system is not balanced. The result was that an original change, the increase in temperature, was amplified. Right? So I'm still using those key terms that we learned in the PowerPoint in my response. Right? So that's exactly what you guys are going to do when you choose 3 out of these 5 examples to read the scenario, identify the type of feedback loop, positive or negative, and then provide a reasoning why, just like I did here. So I'll go ahead and I'll read the next scenarios, and you can just pause or fast forward if you didn't choose the scenario in order to either write your response or go on to the next one. I'm just going to read through them for you. So, scenario 1. As the temperature on Earth increases, permafrost begins to thaw. This permafrost contains large amounts of CO2 and CH4, which are greenhouse gases. Let me fix that for you. As these greenhouse gases are released, they cause more warming, which in turn causes more thawing and more greenhouse gases to be released. So identify what type of feedback loop it is, positive or negative, and explain your reasoning why. So again, I would start out with, this is an example of what kind of feedback loop? So you can include that sentence starter in your response. Led to, right? That connects ideas a lot. You might want to use that in your response. The result was, that's a good one. Right. Let's see, number 2. As CO2 concentrations increase in the atmosphere, more CO2 is absorbed by the oceans through a process of diffusion. This reduces the amount of CO2 in the atmosphere. Again, figure out, are functions just increasing or being amplified, or is there some kind of stability or like return back to normal that's happening at the end? So that should help you determine if this is a positive or negative feedback loop and explain your reason why. Use those same kind of sentence starters and transitions that I did here and highlight it for you. All right, number 3. As the surface temperature of the Earth increases, there are increased levels of evaporation from the oceans. This increased evaporation results in more clouds forming in the lower atmosphere. These clouds, in turn, reflect some radiation back into space, slightly decreasing the surface temperature. So what type of feedback loop is that? And tell me your reasoning why. Number 4. Increasing atmospheric concentrations of CO2 cause temperatures to rise. As temperatures rise, some biomes are prone to drought and forest fires. Forest fires are on the rise, resulting in more combustion of biomass, which releases more CO2 into the atmosphere. So look for your clues. I would highlight your clues pink to signify hints for a negative feedback loop, Or should you be highlighting in green where you see hints for positive feedback loop? Tell me what kind of feedback loop this is and explain your reasoning why. Last one, number 5. The Arctic regions become substantially warmer and frozen. The Arctic regions become substantially warmer and frozen tundras begin to thaw. As it thaws, the tundra develops areas of stagnant water, meaning they're not moving, with little oxygen available under the water as thick organic layers of the tundra begin to decompose. As a result, the organic material experiences anaerobic decomposition that produces CH4, remember that's a greenhouse gas, which should lead to even more global warming. Go back, highlight your clues, pink for negative feedback loop, and green if you think it's a positive feedback loop. Tell me what type of feedback loop that is. Describe the clues that tell you why, that help support your idea that it's a positive or a negative feedback loop. Tell me why.